So you're going to take a quiz that combines both ionic and covalent compounds. And in order to name or write the formula correctly, your very first step is always to recognize if the given substance is ionic or covalent. And you do that by looking at the very first element. If it is a non-metal, then the given compound is a covalent compound. Anytime it's a covalent compound, you need prefixes in the name. Now, what are prefixes? Prefixes are words like mono, di, tri, tetra, etc. Before you take the quiz, make sure you have memorized these prefixes and you are telling it to the person who's sitting next to you. Okay? So in this case, carbon doesn't have any subscript. So we just write the name of the first element, which is carbon. There's 2 oxygen. So that gets a subscript di, and it becomes oxide, carbon dioxide. Let's look at the next element. I'm looking at the very first element. It is a metal, making this substance an ionic compound. Not only do I have to recognize that lithium is a metal, I also have to recognize that it's not a transition metal and it does not require a Roman numeral in its name. Therefore, the name is going to be really easy here. You just write the name of the metal, lithium, and you should be able to recognize the polyatomic ion. It's sulfate. So the name of this compound is just lithium sulfate. The ending is an 8. Let's go to the third compound. This is nitrogen. Nitrogen is a non-metal, making this compound a covalent compound. So nitrogen has the subscript 2, which makes it di. The first element is just nitrogen, but then the second element has 5 as the subscript, making it pent oxide. The next one is barium. Barium is a metal. Therefore, the given substance is ionic. Now, barium again does not need a Roman numeral, so the name of this compound is just going to be barium oxide. The next element is again potassium, a metal, making it ionic, but it contains a polyatomic ion, so it's going to be potassium, and the polyatomic ion is a nitrite, if you recognize it. The next one is phosphorus, making it covalent, so the name of the compound will be phosphorus. The subscript for fluorine is 3, making it trifluoride. Let's scoot over and go to the other side and try to name those compounds. Now, iron is a transition metal. It needs a Roman numeral, and it's an ionic compound. So iron, you need a Roman numeral. It's going to be chloride is the ending. Now, how will you know what the Roman numeral is for iron? You're supposed to look at chlorine. Chlorine, you have to know its charge pattern. You always have to know the charge pattern off of the periodic table. The chlorine is group 17 or a -1. But there are how many chlorine atoms? There are 3 chlorine atoms, making the charge on the chlorine side -3. How do you balance that -3? With a +3 on iron. So the Roman numeral that iron will take will be 3. Let's do the next one. We just talked about iron requiring a Roman numeral. So we're going to write iron in this case. We need a Roman numeral. The oxygen will become oxide. Again, we always start by looking at the non-metal side. If you look at oxygen, you know oxygen is a -2. But there are 3 oxygens. So -2 times 3 will be a -6. -6 is balanced by a +6. But there are 2 iron atoms. Therefore, the charge on each iron atom will be 3, and so the name of this compound is iron 3 oxide. If you go down to number 20, this is a covalent compound because it starts with a non-metal. Oxygen is a non-metal. So you just write the name of the first element, oxygen. Fluorine has a subscript 2, which is di, and it becomes fluoride. The next element is again a covalent compound. So you will have di, you will write nitrogen. Here is one of the exceptions of naming covalent compounds. The first element will never ever get mono, but the second element always has to get a mono, there's one of it. This is dinitrogen monoxide. The next element is an ionic compound. Nickel is a transition metal that needs a Roman numeral, so we will have the name as nickel. We need a Roman numeral and the ending will be bromine. Now again, we look at bromine. It's a halogen with a -1 charge. There are 3 bromine atoms, making it -3 on the bromine side, which will be cancelled by a +3 on nickel. There's only 1 nickel atom, therefore it will take a charge of 3. The next one is gold, again a transition metal. All right, so you have gold, you need a Roman numeral. It will end with a chloride. There are 3 chlorine atoms, each with a -1, making that a -3, or gold will be a +3. Magnesium is an alkali earth metal, does not need a Roman numeral, so it is an ionic compound. It will just be magnesium chloride. I'm going to start with how to name compounds when it involves ionic compounds with Roman numerals, ionic compounds without Roman numerals, and covalent compounds. You can practice the bottom half and you can look up the answer to your blackboard. I'm going to go back and I'm going to write formulas. When you write formulas, the first and most important thing is you have to remember your charge factor. Don't forget that. +1, +2, +3, ±4, -3, -2, -1, and 0. You also have to know your polyatomic ions, and you will know that the name involves a polyatomic ion by looking at the ending. Now, I'm looking at the very first element, name. It has sodium. I know it's a metal. I know it's an ionic compound. So if it's ionic compound, I have to look up charges on the periodic table. Sodium has a charge of +1. Oxygen has a charge of -2. So I am multiplying the sodium side by 2. So therefore the name of this compound, formula of this compound will be Na2. I do not multiply the oxygen side, it will just be an O. If I look at the next one, it starts with carbon. It's a covalent compound. There is no looking up charges or anything like that. In a covalent compound, I'm only focused on the prefixes. Again, you are not switching or doing anything with the prefix. There is no prefix before carbon, so it's just C. There is the prefix tetra before chloride, which means chlorine will get a subscript 4. I look at the next one, it starts with iron. I know it's an ionic compound. Now it's a transition metal whose charge is not listed on the periodic table, but it is provided as a Roman numeral in the name itself. Chlorine, on the other hand, has a charge of -1, which means I multiply the chloride side by 2 to balance out the charges. So the name of this compound is going to be Fe, the formula is going to be FeCl2. If I look at the next one, it starts with sulfur, which is a nonmetal, making this compound covalent. So all I care about is that sulfur is 2, selenium is Se, and that's a 3, and I just put the 3 underneath selenium. Let's go over to the other side and do some more examples here. Calcium is a metal. This is an ionic compound. Calcium has a charge of +2. Sulfide has a charge of -2. Remember, it's just ide. It's not one of the polyatomic ions. So the formula will be just CaS. Potassium is a metal. This is an ionic compound. I have to look up charges. Again, it's an ide. It's just the element. And the name of this compound, I multiply this side by 3. So it's going to be K3N. Again, it starts with nitrogen. It's covalent. I'm not looking up any charges. There is no prefix before nitrogen. It says hydride, which is just hydrogen. There is a tri, which means there are 3 nitrogen atoms. Coming to the next one, cobalt is a transition metal. This is an ionic compound. The charge is listed as a Roman numeral. Now I'm looking carefully at the ending, telling me that this is a polyatomic ion, which is SO3 with a -2 charge. Now I have to balance my charges. I multiply this side by 2, that side by 3. So the final formula of this compound will be CO2, SO3 within brackets, and a 3 outside the bracket. And that's how you arrive at the formula of some of the compounds. You can practice more and look up the answer key on Blackboard. And after 15 minutes, you can get ready for the quiz.